Hello, I'm Seema and welcome to part 20 of the chapter Electrochemistry. In part 19, I was telling you about electrolysis and electrolytic cells. Moving ahead with our discussion of that, in this video I'm going to tell you about the products of electrolysis. But before we come to the products of electrolysis, let us just revise electrolysis a little bit. An electrolytic cell consists of a tank, and in the tank you have an electrolytic solution. The electrolytic solution can be the molten compound, for example sodium chloride molten, or it could be a solution of that particular compound. Either it is in the molten state or it is dissolved, it acts as a solute and it is dissolved in a solvent, for example water. So you have an electrolytic solution and then you have electrodes. Electrodes are two rods that are dipped into the electrolytic cell. These electrodes act as the source of electric current, like the electric, or rather they communicate the electric current. The source is a battery or whatever source you use. The electric current enters the solution and the electrons they leave the solution with the help of these electrodes. Now the electrodes also may be of two types. They may be the inert electrodes or they may be reactive electrodes. So what do we have when electrolysis is occurring? A chemical reaction that is occurring of the ionic compound. Then the solvent that is present that may also undergo changes. And if the electrode is reactive in nature, the electrode may also be participating in the reaction. That may also be undergoing change if the electrode is not inert. So in the electrolytic cell, you can have a number of species. And if you have more than one positive species or more than one negative species, at the anode and the cathode, which are positive and negative, there will be a competition of ions. The ions which are positively charged and the ions which are negatively charged, they would start competing at the electrodes. And the one which has a stronger tendency to lose electrons would come to the anode, and the one which has a stronger tendency to gain electrons would be the reaction that will occur at the cathode. So that is how the products of electrolysis depend on a number of factors. They depend on whether the electrodes are reactive or are the electrodes inert. Are the electrodes participating and contributing some ions which may compete? Then the second factor is the compound in its molten state and there is no competition, or do you have an electrolyte which has been dissolved in a solvent and the solvent is also furnishing ions which may participate in the competition. So all these factors would decide what would be the products of electrolysis. Let us study about it. The products of electrolysis, they depend on the different oxidizing and reducing species and their standard electrode potentials. They do depend on the different species, that is the species that are getting oxidized and the species that are getting reduced. And which one will get oxidized out of the different species or which one will get reduced is determined by the standard electrode potentials. How is that? We'll understand that when I do this example. Now there is a problem that sometimes electrochemical processes, they seem to be feasible. The process, if you look at the standard electrode potential, the potential seems to be fine and the reaction should take place. But the rate of the reaction is so slow, or it may take so long for the reaction to take place that you would not want that. In such cases where the reaction, although feasible, the rate of the reaction is extremely slow, in those cases, what were we doing? What did I tell you in the previous video? That we use electric current to cause a chemical reaction. So when you are using electric current to cause the chemical reaction, and you gave the, theoretically you have calculated that this much of coulombs of energy has to be provided and the reaction will take place. But the reaction that, of course it does take place according to its standard electrode potential, but the reaction is so slow and you want it to be faster. So what do you do? What did you do? What did your mom do when you were young and you would be eating very slowly? She'd say, hurry up, come on. She would, let me put 2 bites in your mouth. So in some way you would have to use a little extra electricity to give it that push so that the reaction speeds up. That extra electricity is known as overpotential. the potential that is required to bring about the change, but on top of it, over it, more potential has to be provided so that the reaction can be speeded up to a normal speed. It is too slow. So when you have a compound or an ion which is competing and which is energetically feasible, but you need an overpotential there, and you would like to save that electricity and you would not like to use the overpotential, maybe there you may get a different product. Simply because the overpotential was not available, and therefore, although this reaction was feasible, it is the other reaction that took place faster, and that became the main reaction at that electrode. So we say that some electrochemical processes, although feasible, are so slow kinetically that overpotential has to be used, which makes them difficult to occur. And when there is a competition, any weakness, whether it is a weakness of having to use overpotential or it is the weakness in just having the electrode potential, the standard electrode potential, which is comparable, in those cases, such an ion would lose the race. Now let us take an example, and with this example you will understand what I am talking about, whatever I told you about the products of electrolysis. If you take molten sodium chloride, that is melted sodium chloride, and you carry out the electrolysis of sodium chloride in the molten state, the electrolyte only has sodium and chloride ions. So at the anode and the cathode, very specific reactions will take place. There is no competition. You're kind of using inert electrodes, and therefore when this happens, when you use molten sodium chloride, the products are sodium and chlorine. At the cathode, you will get sodium. Why? Because sodium is what happens at the cathode. I told you, memorize it. Reduction always occurs at the cathode and oxidation always occurs at the anode. So for reduction of sodium to occur, you have sodium ion, it gains an electron and it gives you sodium atom. And at the anode, the negative ion, that is the chloride ion, is attracted to the positively charged anode. So the chloride ion gets attracted there and it loses an electron. And when it loses the electron, it forms half a molecule of chlorine gas. So the products of electrolysis when you used molten sodium chloride was sodium and chlorine. On the other hand, if we had not used molten sodium chloride and we had dissolved the sodium chloride, that is common salt, into water, now we have a solvent and the electrolyte has been dissolved in it, and the solvent is also contributing its own ions. Now water breaks in the presence of electric current, especially in the presence of an electrolyte. Water molecules, their conductivity also increases and they dissociate into H positive ions and OH negative ions. Now these ions, in addition to the Na positive ions and the Cl negative ions, will be competing at the electrodes. So how do we find out which one would be the product? So if we use aqueous sodium chloride, at the cathode there are two possible reactions. One is the one that happened earlier, that sodium ion will gain an electron and it will result in the formation of sodium. And the hydrogen, the other possibility is from the solvent. That solvent that broke into H positive and OH negative, the H positive ions may also gain electron and result in the formation of half a molecule of hydrogen. Now, if you look at the electrode potentials, at the cathode, it is always reduction that takes place. And when we talk of standard electrode potentials, we are talking of reduction potentials. So any ion which has a higher reduction potential will have a stronger tendency to get reduced, right? Any ion that has a higher reduction potential, it means it has a better tendency to get reduced. That is the one that will get reduced, and the one that has lesser tendency to get reduced or which has a lower standard reduction potential will not get reduced. So if you look at the reduction potentials here, the reduction potential for sodium ion, the tendency of sodium to get reduced is minus 2.71 volts, while the potential required for hydrogen to get reduced is 0 volts, which means that hydrogen has a higher value. So which one would get deposited, or which reaction would take place? H positive combining with electron, that is, the reduction of hydrogen will take place. In the competition, it is hydrogen that will win. And this will win the race, and this is the reaction that will take place, while the other reaction, the sodium ions, do not get converted into sodium atoms, and therefore in the solution now the sodium ions are present. Right? So higher electrode potential is preferred at the cathode, and therefore and the higher electrode potential is of hydrogen, which is 0.00 volts, and that is why this is the reaction that will take place. But H positive is obtained. How is H positive obtained? H positive was not obtained from the electrolyte. It was obtained from the solution, that is the solvent, and the solvent was water. So where did H positive come into the solution from? It came from water. And that reaction that took place was that the water molecule, it broke down into H positive and OH negative ions. So the reaction that took place, the OH negative ions were also furnished in the solution. So now how many ions are present in the solution? Na positive, Cl negative, H positive and OH negative. There are 4 ions. Out of the 2 positive ions, Na positive and H positive, it was the H positive which got reduced. Now let us see, out of the 2 negative ions that are produced, that is Cl negative and OH negative, which one would get oxidized at the anode? We would like to find that out also. But before we come to that, if we say that this is reaction 1, that is the reaction that occurs at the electrode, and the source of this reaction was water, that is the source of the hydrogen was water. If we sum up these two, you will get the net reaction at the cathode. So this was the net reaction. On the whole, this reaction took place, which was due to the cathode. That is, the water molecule gave you H positive and OH negative. So H positive, if you sum these two reactions 1 and 2, H positive and H positive will get cancelled, and you will be left with water plus electron will give you half H2, and OH negative will be left in the solution. So H2O plus electron will give you half H2, and OH negative ions are now furnished to the solution. Now, did you notice that we did not talk about the Na positive ion at all for the reaction at the cathode? Because in the competition, it was H positive, that reaction that actually took place at the cathode. And the Na positive ion, which was produced as a result of the breaking down of NaCl, those Na positive ions are still present in the solution, and they are not a part of the cathode reaction. Now at the anode, again you have two processes which are possible. One is the chloride ion. Chloride ion will lose the electron and form half a molecule of chlorine, and the standard reduction potential of E0 cell is 1.36 volts. The second possibility here is that water molecule will give you oxygen and furnish H positive ions and 4 electrons. The electrode potential for this reaction is 1.23 volts. So H2O actually, now this is again the overall reaction that is taking place. H2O is going to give you H positive and OH negative, right? So the H positive, total H positive which is formed, and the oxygen which is left. Now we are totally separating the H positive and not the OH negative, rather just all the H positive ions. So water will give you oxygen plus 4 H positive ions plus 4 electrons, and the standard electrode potential or reduction potential for this reaction is 1.23 volts. I told you reduction would be preferred for that reaction which has a higher reduction potential, and oxidation is the opposite of reduction, right? So oxidation will be favored for that reaction whose reduction potential is lower. So it has a lower tendency to get reduced, which means, in other words, that it has a stronger or a higher tendency to get oxidized. So at the anode, you will have to look for that reaction which has a lower electrode potential. So this is 1.36 and 1.23. So according to our logic that the standard electrode potential decides which reaction will take place, according to that logic, it is this reaction which should take place at the electrode. But there's a hitch there, that other thing. This reaction requires an overpotential. Did you see what was the natural tendency? H2O breaking down into H positive and OH negative. On the other hand, to get 4 H positive from 2 molecules of water and a molecule of oxygen and 4 electrons, the electrode potential is this much. This reaction would be so slow that it would require overpotential. And since it requires overpotential, although it was more feasible in comparison to the other reaction, yet due to overpotential, this loses the competition and this reaction does not take place. Rather, it is chlorine which gets oxidized. Chloride ions which get oxidized into chlorine gas. So it is this reaction which finally takes place. The chloride ion, which is aqueous, it gives you half a chlorine molecule and electrons are evolved. And although its electrode potential is higher, the reduction potential is higher, yet it is this reaction that takes place at the anode. So these are the factors how they determine what would be the products of electrolysis. So let me just read this. According to the standard electrode potential, reaction 4, now this is 4 and this is 3. Reaction 4 is preferred, but due to overpotential of oxygen, 3 is preferred. What occurs is the reaction 3, that is chloride ion will get oxidized. Thus, how would you write down the net reaction now for the anode? Just as you wrote down the net reaction for the cathode, what would be the net reaction for the anode? The net reaction overall for the entire electrolysis. The overall reaction, net reaction for the entire electrolysis of sodium chloride would be sodium chloride. It gave you sodium ions and chloride ions. At the cathode, water plus electron gave you half hydrogen plus OH negative, and at the anode you had chloride ions plus half Cl2 plus electron. So we have written now the reactions, the overall reaction of the electrolyte, the reaction at the cathode and the anode. So the net reaction would be the sum of all of these reactions. So when you sum all of these up, what do you have on the reactant side? You have sodium chloride, you have water, and you have chloride ions. So the sodium chloride remains, water remains, the chloride ion and chloride ions here, they get cancelled out because this is in the reactant, this is in the product, right? And sodium chloride and H2O is not there on that side and chloride ion is gone. So what you have in the end, you have NaCl plus H2O will give you Na positive plus the electron here and the electron here also get cancelled out. So you have Na positive and you have OH negative from here and half of H2 and half of Cl2. These are the products of the electrolysis. Na positive, half H2, OH negative and half Cl2. And on the reactant side, you have NaCl, you have H2O. So this is the overall reaction of electrolysis that took place. Now there's one more example which gives you an idea of how other factors may affect the products of electrolysis. During the electrolysis of H2SO4, we just take the reaction at anode. There is a competition. You're carrying out the electrolysis of H2SO4 dissolved in water because it is a solution in water. So at anode, the reaction that takes place is there's a possibility of two reactions. One is that water breaks down into oxygen and gives 4H positive plus 4 electrons, the same reaction that we had here, and it requires an overpotential, you remember? And the second possibility is 2SO4 2 negative aqueous, which would give S2OH2 negative plus 2 electrons. So these are the two oxidations that were possible at the anode. Now E0 cell of both we know, and we find that when the concentrations are low, at that time, although you require overpotential for the first reaction, the product is the reaction that takes place at the anode is the first reaction, where water molecule is getting oxidized. But if the concentration of H2SO4 is high, then the product that you get is SO4 2 negative, that is getting oxidized. Isn't it interesting? So it is not only, this particular example shows us that not only are these factors important, that whether the electrode was reactive or not, what was the standard electrode potential, and what was the other factor, whether there was overpotential. The fourth factor would be even the concentration of the solution would build up a competition, and under different concentrations you may get different products of electrolysis. So this was a little information about the products of electrolysis. If you found my video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.